This is problem number 9 from section 2.1. In this problem it says, a rectangle is determined by the stated conditions. Find the slope-intercept form of the 4 lines that outline the rectangle. So I think the first thing we should probably do is just get a visual on this to help us make sense. So I'm going to draw just a little visual. 0, 0's here. Maybe I'll mark that with a different color. So we've got 0, 0. We've got 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4 is up here. And then we've got 3, 5, which is 1, 2, 3. Up here, 1, 2, 3, 5. So we have 3 parts of this rectangle, essentially. Now, we know that from 0, 0 to 4, 4, there's going to be a line. And from essentially 4, 4 to 3, 5, there'll be a line. All right, there's got to be a line between these 2 points and these 2 points if it's going to be a rectangle, right? Because these, I mean, that's just how it's got to be. So let's go ahead and find this equation for the line here. So first thing we're going to do is equation for 0, 0 to 4, 4. So when we go to find this equation, we're going to use the slope to find it. And we'll call this x1, y1, x2, y2. And we're going to say 4, because y2, minus 0 over 4 minus 0 will give you 4 over 4, which is 1. So my slope for the original line is just 1. My y-intercept, because I'm going through, this line's passing through 0, 0, that is the y-intercept. You can see it right there in the picture. That's the y-intercept. So I can say that my original line, so this first line, we'll call it y1 because it's the first line, is just slope of 1. So we'll go back to this slope-intercept form. Slope of 1, and so we'll just end up with 1x, or we can call that y1 equals x. Okay, now the key here is if this line right here is part of a rectangle, then we have another line that is exactly parallel. Because remember, whenever you make a rectangle, right, you have 2 lines that are parallel, top and bottom, 2 lines that are parallel side to side. So we know that we have a parallel line to this equation right here. But before we get to that, let's go ahead and find the other equation we know we need to find, which is from 4, 4, because this is going to be one of our, I'll kind of mark it here, this is going to be one of our lines, which we just found, y equals x. This will be the other one, and then we're just going to find these 2 lines here to outline this box. It'll kind of look like this. Okay? So let's go ahead and find the equation for the line between 4, 4 and 3, 5. So we'll say equation for 4, 4 to 3, 5. And we'll call this x1, y1, x2, y2. And again, we're going to use our slope to start this out. So m equals 5 minus 4 over 3 minus 4. So it's 1 over negative 1, which is negative 1. So our slope there is negative 1. Now you'll notice we don't have the y-intercept here. All right, we don't have the y-intercept here. So we need to find that y-intercept. Now to do that, we can just use point-slope form. So let's go ahead and write y minus y1, which is our 4, equals negative 1. And then we'll say x minus x1, which is also 4. When we do that, we end up with y minus 4 equals negative x plus 4. Add the 4 over, we get y equals negative x plus 8. So, and we'll call this line 2. Now, line 1 is right here. Line 2 is right here. We have now two sides of this rectangle. We need to find side 3. All right, so we've got basically found, we'll call this like, this is the y1. We found y2. Now we need to find y3, which is parallel to y1, and we also need to find y4, which is parallel to y2. So we need to find y3, and it's parallel to y1. But we know that this is like, if we turn this sideways here, turn this piece sideways, we know this is our 0, 0. I'll kind of write that here. This is our 4, 4. And this is 3, 5. So we found the equation for 0, 0, 4, 4 right here. So the next line that we got to find is parallel to that, but it goes through 3, 5. So because this is parallel, we're going to say, or because this slope is 1, we're going to say, we're going to write a parallel line. So we're going to write parallel to y1 equals x through 3, 5, because that's what we need. Okay, so let's go ahead and write that out. We start with point slope form, and we're going to write y minus, this is x1 and y1, so 5 equals, this is a slope of 1, so we'll say 1x minus 3. And we know that's going to equal, slide up just a second, we know that that's going to equal y minus 5 equals x minus 3. Add the 5 over, and we end up with y equals x plus 2. So this is y3. So this is my third line now. This line is parallel to this line. They have the same slope, but we're going through, and if I drew this a little better, you can see it's a little wide. This would go right through that y-intercept of 2 there. And then finally, we need to find this line here, right, which is our y4. It's got to be parallel to the line that goes through 4, 4, and 3, 5. So it's got to have a slope of negative 1. But it goes through the origin, which is 0, 0. Well, that's pretty easy to find then. So if we're going to say parallel to y, and we called this y2, through 0, 0. Well, we know the slope is negative 1, so we can say y equals negative 1x, and we know the y-intercept is 0, so plus 0, which is just y equals negative x, and we'll call that y4. So our 4 lines, we've got y1 and y3 being parallel to each other. We've got y2 and y4 being parallel to each other. And that's how we know we have a rectangle, because they all connect at the corners, but they're parallel to each other. That's the definition of a rectangle.